Good morning. Last lecture we have seen the definition of conditional probability and independence, and we have seen the independence of two events, and we have solved the numerical problem on the independence of two events. And in this lecture we have seen the result one, that is if A and B are independent event with probability of event A and probability of event B both non-zero, then A and B cannot be mutually exclusive. Here we have proof since A and B are independent, that is probability of A intersection B equal to probability of A into probability of B is not equal to 0, and therefore probability of A equal to not 0 and probability of B is not equal to 0, and therefore A and B cannot be mutually exclusive. Here we have proved that A and B are independent even with probability of A and probability of B both non-zero. Then A and B cannot be mutually exclusive. Here we have proved that since A and B are independent, that is probability of event A intersection B, that is equal to probability of A into probability of B is not equal to 0, and that is probability of A is not equal to 0 and probability of B is not equal to 0, and therefore A and B cannot be mutually exclusive. Then again we see the result second, if A and B are mutually exclusive event with probability of A and probability of B both non-zero, then A and B cannot be independent, that is A and B are dependent. Since proof we have proved this result, since A and B are mutually exclusive, that is A intersection B is equal to empty set, and therefore probability of A intersection B equal to 0. However, probability of event A and into probability of event B is not equal to 0. We have proved that this condition in result 1, and probability of A is not equal to 0 and probability of B is not equal to 0, and therefore probability of event A intersection B is not equal to probability of A into probability of B, and therefore A and B are not independent event, that is A and B are dependent event. That is, we have seen the example of this result depend on this result, that is consider the experiment of tossing three pairs of coins simultaneously. Here we have tossed the three coin pairs simultaneously and we get the sample space or sample that is omega equal to here 8 outcomes, that is head 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 tail head tail head tail head 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 tail 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 head tail 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 head and tail tail tail. That is number of sample space, that is n of omega equal to n, where total number of element in sample space is 8, and then we have find that is event A equal to getting all heads or tails, that is we have getting the all head or all tail in the number of element in the sample space, that is here A equal to here 1 all head is 1 that is H here is one event, and tail T is that is one event, that is getting all head or tail in the number of element in A equal to n of A equal to 2, and then we find the probability of event A, that is getting all head or tail equal to n of A into n of omega, that is equal to n of A is the favorable event is equal to 2. Divide number of total sample space is 8, that is 2 by 8 equal to 1 by 4. And let B equal to occurrence of getting at least 2 tails. At least 2 tails. Here we have get 2 tails is the sample in the sample space, that is HTT, THT, TTH and TTT. Here number of element in the B is equal to 4, and then probability of event B equal to n by B divide n by omega, that is total sample space, that is number of element in B equal to 4 by total number of sample space is 8. 4 by 8 equal to 1 by 2. And now A intersection B, that is we have get the A intersection B is the common only TTT. Here TTT, that is A intersection B equal to 1 sample space, that is number of element in A intersection B equal to 1, and that is probability of A intersection B equal to number of element in A intersection B divide total sample space, that is A intersection B is 1 element divide 8, and probability of A into probability of B equal to that is probability of A is 1 by 4 and probability of B equal to 1 by 2 and equal to 1 by 4 into 2 8, and therefore by definition A are and B are independent but not mutually exclusive. Here we have proved the by definition A and B are independent but not mutually exclusive.